All right, 11.3 is geometric sequences. We've already, so the difference between a sequence is when you just have a whole bunch of terms, and a series is the sum of all those terms. So they're kind of interchangeable. And geometric means that you have a common ratio. We've already been working with this a little bit from 11.1. Common ratio, it's what you multiply by. So I have 5, and then 10, and then 20, and 40, and blurry. What's my common ratio here? 2. Very good. So this is the sequence that, well, you could write the nth term. The nth term, a sub n, is equal to your initial term, which is 5, times your common ratio, which is 2, to the n minus 1. So it's just your initial term times the common ratio to the n minus 1. So if this was, that's my first, second, third, fourth, I could check. If I put 4 in for n, do I get 40? A sub 4 equals 5 times 2 to the 4 minus 1, 5 times 2 cubed, which is 8 times 5, which is 40. So it checks out. So I want you to try to find the nth term of this geometric sequence. Give you a hard one to start with, especially since it's blurry. Alright, try to find the nth term of that. What is my common ratio?
1/3.
1/3, very good. So the nth term would be 12 times 1/3 to the n minus 1. My gosh, stay focused, please. How many got that? Good. So I'll do one more of these. How about find the 10th term? So before you find the 10th term, what? I think it's too dark in here. Why is it not focusing? Find the 10th. Before you find the 10th term, find the nth term. Let's go with. So find the nth term and then find the 10th term. Keely, what's my common ratio? -3, very good. So our initial is 2, so a sub n equals 2 times -3 to the n minus 1. And then you just have to find the 10th term, so it's 2 times -3 to the 10 minus 1, so 9, and whatever that is. Anybody actually have an answer for that?
-39,366.
366?
Yeah.
It's a lot of divisible by 3 numbers. Okay, questions on that? Finding the nth term, finding any term? That's pretty straightforward. It's nice that you just need to know your initial and what you're multiplying by, and then it's the same formula every time. There's 2 different types of geometric series. You've got the finite one and you've got an infinite one. They each have different formulas. So sum of a finite series is a sub 1 minus r to the n over 1 minus r. Now the a sub 1 doesn't necessarily have to be term number 1, it just has to be the first one. So if you started with 0, it'd be the 0 term. Just think of this as the first term, and then 1 minus r is your common ratio to the n. What is n again?
Term.
It's how many terms there are. Terms, and then it's divided by 1 minus r. Alright, so if I wanted to find the sum of
What's R?
Common ratio. Alright, so let's say we're trying to figure this out without like literally adding up all 10 terms. We could just use our formula. It's finite because it does end, it goes to 10. If it went to infinity, then we would use a different formula. Okay, so in this one we have what's my first term?
32.
8, 11.2, 3 different possibilities for my first term. It looks like it's 8, right? Except if you plug in 1, that's not going to get you 8 because it's not n minus 1. It's 1.4 to the first times.
1.4. I was doing 1 comma 4.
Yeah, I thought it was 1
Like a
comma 4.
comma or something.
Oh, really? Yeah, it's 1. Ashley, did you say?
I did 1.2.
Yeah, that sounds like it would be right. So if you plug 1 in, your first term is 8 times 1.4 to the 1. You ask your calculator what that is, and you get 11.2. So that's my first term. If that started with 0, right here, what would my first term be?
8.
It would be 8. So pay attention to what it starts with. Pay attention. Always just plug that number into your formula here, and that'll give you your first term, whatever that is, whether it's 0 or 1. Okay, so we have our first. That's 11.2 times 1 minus, what's my r? What's my 1.4? Whatever is being taken to the n is my r. Okay, 1 minus 1.4 to the n. In this case, what's my n?
10?
It is 10. Very good. Is it always that number?
No.
I said the word always, so you're thinking. When would it not be that number?
Infinite?
Well, no, if it's actually a number up there, can we always assume that that is n? Can you think of one where it would not be n? What did you say?
I thought you meant like the number 10.
Oh. Anybody know when that would not be n?
It was 0?
Very good. If we started at 0, what would my n be? How many terms would there be then? There'd be 11.
Oh, and plus
If you
1.
started with 0 here, you'd have the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you'd end up with 11 terms. If that's a 1, you'll always have that number. So basically, if you want to remember it, it's this number minus this number plus 1. That's how many terms are. So in this case, it is 10 over 1 minus r, which is 1.4. Okay, so now we can just plug that in. That will give me the sum of the first 10 terms right there. Okay, I assume we can do that on a calculator. Questions on that? Do you want to try one?
7,
My
9,
brain
8,
is kind of messed up.
1.4.
It's a lot to learn. And having a quiz.
You'll be alright. You're smart.
But weren't you the person that said that like in the beginning you needed time? Like this amount of time that you bring?
What's the answer to that one?
I don't know. I just made it up.
Well,
I'm going to pot.
We got 2 different answers.
You got 2 different answers. You can't use calculators correctly? Did you put this 1 minus 1.4 in parentheses when you divide it? You have to.
In the same parentheses as this top one?
Well, you could put the top one in parentheses and then divide the bottom one in parentheses. I'd put them both in their own parentheses.
Yeah, and then I put the parentheses around all that.
So you got a parenthesis over.
I have 1 minus 1.4 to the 10 in parentheses,
Okay.
divided by 1 minus 1.4 in parentheses.
And then times
Put both
11.
of those in parentheses.
And then times 11.2?
Yeah.
Sounds like you'd get the right answer.
Okay. So I'm
All right, so we'll move on. Sum of a finite. Sum, or of infinite. Infinite? I'm having a hard time. Infinite series. These are all in your notes. This one's actually easier. It's the first term over 1 minus r. That's it. That'll add up an infinite amount of terms. The first term over 1 minus r. Okay, here is the requirements though. R has to be between -1 and 1. Okay, so if I go back up here and if I add these up to infinity, what's my answer going to be? If I keep multiplying by 1.4 and adding them up, what am I going to end up getting?
infinite.
Infinity. It's getting bigger and bigger and bigger. Is this exponential growth or decay? Growth. So we know that if we're doing growth, it's gonna, if we just keep adding up terms, it's gonna go forever. We're gonna get infinity. Okay? So our r has to be exponential decay in order for it to add up to a number. So it goes down like this and it approaches 0. Okay? In order for it to be decay, r has to be between -1 and 1. For those going on in Calc 2 eventually, this right here is a huge part of an entire chapter. It's pretty significant. Okay, so if I have 6 times 1/3 to the n, and I'll go from 0 to infinity. It is an infinite geometric series here. Okay, so all you need to know is the first term. What is my first term?
0.
I've heard 0, 2, and 6.
6.
Plug in 0. What do we get?
I didn't see the n equals 0.
6.
Okay, so our first term is 6. What's my r? 1/3. 6 divided by 2/3 is 6 times 3/2, which is 9. If we add up every single one of those terms to infinity, you will get 9. Okay, and that only works if r is between -1 and 1 for an infinite series.
So if it's -1, would the bottom be -2 or 0?
If it's -1
Yeah.
for your r,
Yeah.
it can't be -1.
Or close to
-1/2 or something?
Yeah. Something like that.
Yeah, then you'd get positive on the bottom, right?
Yeah.
Is that what you asked me?
Yeah.
Okay. Here, why don't you try one?
Math is weird.
Find the sum. All right, I'll give you a second to try it. I'll write the formula. It's a hard one. First term over 1 minus r. There you go. All right, so let's try it. Our first term, I plug 1 in, I get 1/5 to the first, so 4 times 1/5 is 4/5, divided by 1 minus our r, which is 1/5. 4/5 divided by 4/5, even I can do that math. It is 6. Just kidding. So we got 1. Okay, so that's a sum of an infinite geometric series. All right, the only other problem that I would help you with is it's an interest problem. Maybe I'll do a quick video of that tomorrow. time.